So Opamp. Okay, there are two branches which take two resistors connected to voltage sources. Let's say V1, V2, let's call this R1, R2, RF, V out, and then let's connect this to ground. Okay, so here we have two inputs, and our goal is to figure out how are the outputs related to the inputs. The claim is that this circuit will act as a summer, which is just sum the two voltages some fashion. So compute P out as a function of P1 and V2. Okay, so it's turns out nothing is too different here. It's everything is pretty much the same. Let's see how to do this. Okay. Put a new page. Okay, so first let's set up currents so that we can then use the currents to relate the voltage differences. So let's say this is I1, this is I2, this is I out. Now this point and this point, since there is no resistor between those 2 points. Those 2 points are essentially the same potential. Okay, so let's just call that we call that V was VC, which is same as VC. The voltage there is the same. And I think we are all set to start writing the equations now. So again, I'm trying to relate V out with V1 and V2. So let's just try to write equations for V out, V1, and V2. And what helps me to do that is VC, because VC is sort of in between. So V out minus VC should be equal to the potential drop across RF. Then we have V1 is here, VC is there. So V1 minus VC is the potential drop across R1. V2 minus VC is the potential drop across R2. Okay, so from these 3 equations, we see that, okay, some people like to do it this way. We see that the unknowns are I out, I1, I2, VC. And let's assume that we know V1 and V2 because those are our inputs, right? So V out is a unknown. So we have 5 unknowns, which I wrote down, but we only have 3 equations. So we need to generate 2 more equations. Let's just do that. So those equations will probably come from the Opamp assumptions. One of the assumptions is that V plus is V minus. Now, this is a problem because we've introduced more unknowns here. So we need to eliminate them as fast as possible. So we see that VC, since VC is the same as V minus because it's connected to the negative end, we can write that down. And then we also see that the V positive, maybe I should just write it down. V minus, V positive. So we can see that V positive is connected to the ground. That should be 0. Okay, so from these 3 equations, we can see that V plus VC and V minus are all the same potential, 0. So V plus is V minus is VC is 0. Okay, so this eliminates one of the unknowns. Okay, but we still need to solve for the other one. So let's see how we can relate them. Okay, we can write an expression for I1, I2, and I out, because what's happening is I out is going to C, and I2 and I1 are also going to C effectively. It doesn't really matter that C are two different points. You can just wire them up at the same point. Really doesn't matter. There's no resistance. So I can write I out plus I1 plus I2 equals the current flowing to the negative end or the inverting input, but the current flowing in an op-amp is 0. Okay, so what I can do now is, so it turns out that let's see, I wrote 1, 2, 3, 4, 5. Yeah. So fifth equation was this. Yeah. So what I can do is I can eliminate the i's using this third expression. So I'm just going to substitute the value for I out. It's V out divided by RF. Right. Second one, I1 is V1 divided by R1, and I2 is V2 divided by R2, all equal to 0. And so we can write P out is minus RF V1 divided by R1 plus V2 divided by R2. You can see that it's not really summing V1 and V2, it's summing some fraction of V1 and some fraction of V2, right? 1 divided by R1 plus times V1 plus 1 divided by R2 times V2. The best way you can do to sum them up is to just choose the resistors R1, R2 such that they're the same. So if you take R1, R2 equals R, and why you can do this, because you're the designer, you build the circuit, so you can do whatever you want with the resistors. So if you do this, then we have V out is minus RF divided by R, V1 plus V2. And that's the summer for you. It sums the voltages V1, V2. The only thing you need to take care is ensure that the resistors R1, R2 are chosen to be equal. Okay, so that is a summer. You should think of an application where this could be used.